this cart, that eliminates having to have someone extra help you load stuff too. You can pump that up, so you can slide the sheets off by yourself. That's another big plus. This machine, he's going to eliminate some woodworkers.
Okay, so I'm going to load the machine, load the material onto the machine. I've got a vacuum pot here. Turn it on. This allows me to drag and slide this thing around. I don't know if you can hear it in the video, but this is not just a vacuum table. This is also an air hockey table. We're blowing air up through both sheets, right? And what that does makes it really easy to move these sheets around, especially when it comes to melamine or any kind of pre-finished material. So what this thing's waiting for now, it's got 3 pop-up pins that have popped up. I'm going to hit all 3 pins. Once I hit all 3 pins, the vacuum kicks on and the pins get out of the way so I can continue cutting. Okay. Click 2, press start.
Yeah, I got this.
Okay, so while this thing's cutting, what we have up here is our run screen. So that gives you, eventually it'll tell you how long it's going to take to run this sheet, along with the entire job time. See, I've got about a little over 6 minutes to run this sheet, and then I've got just a little under 10 minutes to run the entire job left. Now the big progress bar here, that's useful. I could be edge banding right now, and all I have to do is glance back at that, and that gives me an idea of when I can move back to the machine or something. Now in most cabinets, there's probably at least one part that's got to be machined from both sides, right? We do something a little different from everybody else. We don't cut a part out and then flip it and then machine the back side of it to finish it up. What we do is we do the back side of the entire sheet first. Then we come in and we cut notches on the 3 sides, or on 2 sides of it. So when we flip it, it locates right back to the pin and everything. All the front cuts match the back cuts. So it's telling me to fix material. So what I'm going to do, once again, vacuum rod, I'm going to slide it up into the clamp. I'm going to walk right around the front here. I'm going to turn the lever, and it's going to flip apart. Okay, once you're done, pull it back out. You hit your button, you raise the pins up. Relocate it. Once again, you hit all 3 pins. Vacuum kicks on, and then the pins move out of the way. And you're off and cutting it up. Now you'll notice back here we've got 12 different positions, and then we've got a position with a yellow clicker, and that's the drop-off location. So anytime you need to look at a tool, you tell it which one you want to look at, and it'll go grab it and put it in that position. That prevents you from putting tools back in the wrong spot. Now there are 3 other icons at the bottom of the screen. You have your next diagram. You have the remaining tool life for the current tool that's in the spindle. then the red circle indicates that there are some maintenance items that need to be performed. Now, when you actually go to perform those, we tell you how to do it, obviously just with instructions, but we also have show me videos. So anytime you've got a question or you have a maintenance item, there's always a video there to show you how to do it. If you still have a hard time with that, we have what we call virtual service. So you hit a button, it calls directly into our technicians back in Thermwood. You get a live guy, he can see the inside of the controller, and he can see what's all going on. 9 times out of 10, we can fix those minor issues that way instead of sending the guy out. Lots of things can happen during the manufacturing process, right? Earlier I told you about broken tool. If I break a tool right now, the only thing I have to do is hit one of the buttons on my remote. And you're going to have some options to choose from. You can start the sheet over, you can continue cutting where we're at right now. But let's say I broke this tool. So I'm going to say inspect and replace current tool. It's going to drop that tool off back there on the drop-off location. At this point, I can replace the tool, put it right back in the holder, hit start. And if I tell it that it was worn out, it's going to log the life of that tool. Okay? So over time, it's going to slowly start learning your material that you're running. And then it'll start prompting you when you need to start changing parts. I'm going to go ahead and say it was broken. And we'll hit start. So what it's going to do is it's going to check to make sure I put the tool back correctly. Right? So it's going to measure the length and the diameter, make sure I put the correct style of tool in. And then we can continue cutting just about where we're left off.
Since where it was like losing, like, you know, it was worn out, since where it was at that point, it redo that part of that section, start that?
Yeah, so what it's going to do, it doesn't know exactly where the tool being broke at, right? So it's going to retrace a lot of these steps with the new diameter.
So the depth it would have been at, and then keep going?
Yes, yeah. As a matter of fact, all I have to do is hit start at this point, and the battery's going to load. So as you can see, it's going to go right over those. Going from the background right now, right? So the best thing about AI-powered type software is you don't really realize that it's being run. You know, it's not. You don't realize it's working in the background. For instance, as it's cutting through all these parts, it's etching into this wasteboard, right? And I lose all kinds of vacuum underneath those channels. This machine, in real time, keeps track of all that information. So if I've got a big part, normally that I could cut out of one pass, if I've got a bunch of vacuum leaks underneath here, it's going to know, and it's going to possibly take 2 passes at it. If it's extremely bad, it's going to cut all the way down to about 20 thousandths, and then it's going to leave that skin there for you so the part don't move. Alright, I think it's going to start cutting the outlines on these. Yeah. So it's going to start cutting the bigger parts and the smaller parts. Now when it starts with the smaller parts, it knows there's not enough vacuum to hold those small pieces. So it's going to do the same thing. It's going to cut almost all the way through, and then it's going to come back and clean it up. So you can see here it's actually coming back and removing the skin. And it also knows to slow down in certain areas so you don't clip the part out. Okay, so it's done cutting. If you notice, it even squared up the all-fall for us. Okay, there's a reason for that. It's going to get a label. We can scan that and use that on our next job. The labels come out on the front of the machine. We have our Dymo label maker here, so we've got all the labels here. And I'll show you how this works. All the parts have numbers that correspond with the numbers on the label. And if you'd like a close-up of that, let me show you what those labels look like on the part. You've got a few things here. You've got the cabinet letter designation. You may have parts for 5 different cabinets on that sheet. You need a quick, easy way of sorting those things out. So all the parts of OE would go together to make one cabinet, AB, the second cabinet, and so forth. If you get parts mixed up between jobs, green job, blue job, yellow job, red job, we just black out the ones that we don't want. If I drop this on the way to the edge bander, I damage my part, I just need to cut this part. I don't need the whole cabinet. I take my barcode scanner, I scan that QR code. Yeah. I can then scan the QR code on the leftover offal, and we can recut just that part. And I don't have to create a single program. As a matter of fact, there's not a single program that exists on this machine that came from us. Every one of them is self-generated from the Cut Ready software. Okay. If you need further proof of that, we have combination cabinets, right? So say you've got a 4-open type combination cabinet. You know how many different combinations you can make of that? I've tried to do the math, and if I told you the number, you wouldn't believe it. But so that all has to be built right here inside the controller, nested, programs itself, and then it tells you how to run the machine. So I'm going to go ahead and put these labels on the part, and then there's some features on these parts that I want to show you too. So all I have to do is just turn the screen around. I've told it that I'm working from the left side of the machine. So part 1 gets label 1, and so forth. Can't forget the offal. A lot of times, if you start building up several pieces of offal, I'll keep a little rack next to the machine. So the next time I need half-inch material, I'll scan all my offal and I'll let the computer sort it all out and figure it out. It'll tell you which way to orientate it, load it, and all that. Putting these things together, you've never put one together before, they're pretty easy. We put assembly marks on each joint. So we've got 2 dots, a space, and 1 dot on the dado, right? So all I have to do is find the tenon with the matching ones. So you've got 2 dots, a space, and 1. They face each other. You can't put this thing together. You can't get your partitions in upside down. I mean, you can, but you gotta want to. We see how that goes. Now, I didn't tell it what type of slides I planned on using or anything, so we stuck a universal pattern in there. And the way that works is you'll take a 1/4-inch pin, 2 of them, you'll put them in the top sets of holes, you'll set your slide on top of it, and that gets you pretty level. Okay? If you're using undermount slides, you move the pins down to the 2nd set. If you know the pattern, you just tell it, it'll drill the slide pattern in there for you if you need it. And then since this is a face frame cabinet, we do have a modified pocket screw type pattern that we put in. If you can get a closer look on this, you'll see that there's a little shelf right at the top of that. And that is where you put the tip of your pocket screw, and then you lay it down, and that puts you at the perfect angle. You can't do the pre-drill hole though, because our head won't tilt on this machine. Now, let's say I damage this part. So what I'm going to do is I'm going to back out of this. Obviously, it's going to remember where it left off. And what I'm going to do is I'm going to go run existing job, recut parts in the bottom left. I'm going to take my barcode scanner, I'm going to scan the part, and you'll see on the screen, there's my part. So let's hit continue. What kind of material am I going to use? Well, let's use this leftover piece here. So I'll hit the button on there, I'll scan this. Now at this point, I can hit continue and we can cut just this part out. Other types of machines, you're going to have to go back to the desk. You're going to have to make a program for just that one part. You know, these things take time. Time is money. Here with the cut center, you can knock all this out in a matter of no time. You break a tool, we got a slick way of recovering from it. It maps all of the vacuum leaks that were created from creating the etches into the top board. So I'll tell you what, let's cut a dovetail drawer box for this cabinet. So we've got the cabinet parts, but we don't have the drawer box. So I'm going to back out of this. We're going to cut the dovetail drawer box out of this leftover piece. To do that, I'm going to make something new. We're going to go drawers. These drawers are for a cabinet job, or I can select something else and I can put in my own numbers. But the software's already got all the information on it already. So we'll go, it's for a cabinet job, and it's for the one that we just ran. We'll go with side mount slides, and we'll go with a dovetail type drawer box with a full thickness case for the bottom. And if you want to see what the drawer box looks like in 3D, you hit the 3D button. You can rotate, explode, do all that. This is a side mount slide type drawer box. If you do under mount, it will put the capture hole in the back, and it will recess the bottom of the drawer box up along with the back. Now, if you outsource your drawer boxes or your MDF doors, all you have to do is hit the print list. You can print out all the sizes, hand that off to your supplier. But we're going to make ours. So I'm going to hit continue. I'm going to tell it that I'm going to use this piece of ball foam. And by the way, I'm telling it how thick my edge banding is too, because it will undersize the part by that much. If you have a pre-mill edge bander, you just set that value to 0. Okay, we're ready to go. It's telling me it's going to take one sheet of off-fall. So I'm going to hit start to begin. It's going to tell me to load this sheet, right? So it's going to show me the orientation and everything in relationship to the top of it.
Second floor, you know.
So I'll push the part into location. It's dropped. That's what's on. All I have to do is hit start at this point. And it's going to look through all the tools back there. It's going to figure out which one's going to work best. It's going to look at the material it's cutting. It's going to figure out which direction it needs to cut, and how deep it's allowed to cut, and how fast. Dovetail drawer boxes, they do take a little more time because it has to get in there and cut all those fingers out with a small 1/4-inch bit. have that from time to time, but that's why you got this thing. You just pause it, move it out of the way, and so right now it's somewhat sizing the bar, but it's more or less clearing the way for the dovetail tool to go in there and work its magic. Again, I'll apply my labels. Alright, I'm going to need your help. I'm tall, but I'm not that tall. Well, you're not doing a very good job because you put it on upside down. That is, well, I got that. Alright, and then I've got, once again, another off-all sticker, and we'll just cover up the old one. Now, putting these things together, pretty simple. Of course, I always like to do things backwards, so we're going to start with the front down first, which means the left goes to the right goes to the left, and then we'll start putting these together. Snap that. Have assembly marks. Make sure those line up. Pop this one on. This around, put the last little piece on. Got you a nice little joint there. And then as far as the inside, well, you might have to put some clamps on. See, the actually fit together real nice. All right. Good? All right. And then the doors are the same way. We can do MDF doors. If I back out of here. We could go make something new. Doors. We could do it for a cabinet job or something else. That's all I'm going to do for something else. We've got two different types of MDF doors. We've got the multi-pass, which uses a series of ball nose tools and it'll essentially carve it out. And then you've got your single pass doors where it uses an actual diamond tool profile to it. So it makes one single pass. Slinky door. In this case, we'll do let's just do a main style. We'll just go with that first one there. Add that to the job. And then let me go get some MDF and clear this table out, and I'll go ahead and get an MDF door started. I'm going to scan in the off fob. And then I'll hit continue. I'm going to let it basically program itself. I will. Yeah, it'll tell me when the